Welcome to Intro to Polar Coordinates and Polar Curves. So the idea here, we are used to working in the rectangular system. So the rectangular coordinate system. Right, where we plot positions X and Y. But this is not the only way that we can give a coordinate. Okay. So, but this is not the only way to give a coordinate. An alternative way is to use polar coordinates. Which are denoted P for polar, and then in parentheses, R, comma, theta. The R tells us the point lies on the circle of radius R, centered at the origin. And the location on that circle is angle theta from the positive x-axis. So for example, let's plot the polar coordinates, 2 comma pi, -1 comma pi over 3, and 2 comma negative pi over 4. So the usual way to do this is to essentially imagine the unit circle. In the coordinate system. So let's draw a circle centered at the origin. Then we have various angles. So we know that the positive x-axis corresponds to theta equaling 0. Then we have pi over 4 is halfway between the x-axis and the y-axis. The y-axis, positive y-axis, corresponds to theta being pi over 2. The negative x-axis corresponds to theta being pi. The negative y-axis corresponds to theta being 3 pi over 2. Okay. We have all of our sort of common unit circle angles of pi over 6, pi over 3, etc. Okay. So I'm going to draw a series of circles. The first circle has radius 1. Then our second circle has radius 2. We'd have another circle around with radius 3. We could draw circles of radius 2.5, circles of radius square root 3, etc. Right? There are infinitely many circles of any possible radius we could think of. This is sort of the general idea for our polar system. So if we want the polar coordinate 2, pi, this means that the point lies on the circle of radius 2. At angle pi. So the circle of radius 2 and angle pi, we're going to lie on the negative x-axis, that's angle pi, and circle of radius 2, we're on that second circle out. The next one, we're going to be on angle pi over 3. So -1, pi over 3, we're on angle pi over 3. We would be, and then we have a radius of -1, so we're actually going to go in the opposite direction. And so we'll actually be on the angle pi over 3 plus pi to take us in the opposite direction. So to do p -1 pi over 3, we're on the circle of radius 1. The -1 implies that we go in the opposite direction of angle pi over 3. So it is possible to have a negative radius. It simply means that we go in the opposite direction from what the angle would usually tell us. And then if we want to do p of 2 -pi over 4, -pi over 4 would put us down in the third quadrant, sorry, the fourth quadrant. So here's our -pi over 4 as our angle. And then we are at on the second, or radius 2, so we're on that second circle out. So again, this is the point. Oops. So this particular point in green corresponds to the point P2, pi over 4. The point I drew in blue corresponds to P -1, pi over 3. The point I drew in purple corresponded to P of 2, pi. Now note that P of -1, pi over 3 could also be P of 1, 4 pi over 3. So polar coordinates are not unique. Multiple different coordinates can yield the same position on the coordinate system. So just note, polar coordinates are not unique. So for example, P of 1, 4 pi over 3 is the same as P of -1 pi over 3 is the same as P of 1, -2 pi over 3. And then of course, if you go beyond 2 pi, we can go as large as we wanted if we kept going, but usually we limit ourselves 0 to 2 pi. So let's go ahead and just see what happens. We're going to plot the equation r equals 1 plus sine of theta on the domain 0 is less than or equal to theta is less than or equal to 2 pi and see what we get. So let's plot points. So we will have theta and r. And let's start with 0, pi over 4, pi over 2, 3 pi over 4, pi, and then 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Now we don't have to hit everything on all of our sort of usual things on the unit circle, but it's useful to hit quite a few points. So if theta is 0, then 1 plus sine of 0 is 1. So at angle 0, our radius is 1. Let me actually shift this entire thing over to the side and we can just draw a graph on the right. So if I draw my graph on the right, one plus sine of theta can never be bigger than 2. So I know the farthest out I'm going to have to go is radius 2. So I'll just draw 2 circles. Radius 1 and radius 2. So at theta equals 0. So on the positive x-axis, we have radius 1. So we're just on the positive x-axis at position of x-coordinate of 1. Pi over 4, we would be looking at 1 plus sine of pi over 4. Actually, instead of doing pi over 4, the signs are convenient on the pi over 6s. So let's do pi over 6, then pi over 2. And then let's do 5 pi over 6, pi. And then we'll do 7 pi over 6, 3 pi over 2, and 11 pi over 6. So pi over 6 sine is just 1/2. So we're looking at 1 plus sine of pi over 6 is 1 plus 1/2, otherwise known as 1.5. Then we have 1 plus sine of pi over 2, which is 1 plus 1, otherwise known as 2. So plotting these next 2 points we just found at pi over 6, so at angle pi over 6, our radius is 1.5, so we're halfway between the circle of radius 1 and the circle of radius 2. At pi over 2, we're at radius 2. If we continue working our way through at 5 pi over 6, sine is again 1/2. And so we would get 1.5. At pi, sine is 0. So we just get 1. At 7 pi over 6, sine is negative 1/2. So we would have 0.5 as our radius. At 3 pi over 2, Sine is -1, so we get 0. At 11 pi over 6, we will be looking at, again, -1/2 for our sine, and so we wind up with 0.5. And at 2 pi, sine is back to 0. So we're back to 1. So if we continue working through here, again, at 5 pi over 6, we were at the position of 1.5 for our radius. At pi, our radius was 1. At 7 pi over 6, we have radius 1/2. At 3 pi over 2, we have radius 0. That puts us right on the origin. At 11 pi over 6, we're back to 1/2. And then at 2 pi, we're back to radius 1. So if I trace the points sort of going in order as I hit them, I slowly loop my way out to 2 as I work my way clockwise. And then I sort of cycle back in to a radius of 0 as I work my way, continue clockwise. And then I work my way back out and I get kind of an upside down heart. So this is how we can go about plotting points. Note in this particular problem, all of the radii were positive, so I didn't have to worry about that reflection across, or the sort of reflection into the opposite angle or straight across. But again, this is polar coordinates, kind of how we plot them, how we read them. In the next video, we will take a look at how we can go back and forth between polar and our typical rectangular coordinates.